Okay, guys, let's pick it up where we left off. We're about to jump into practice problem number 7. Just to recap what we've been doing so far, we put it all together in practice problem number 6 in the previous video. And kind of the general idea for your most common problem is you have to find a z-score, and then once you have the z-score, then you use the table to look up the probability for it. Of course, there's all kinds of nuances that come with that, but that's the general idea. So what do you need to calculate a z-score? You need a data value, that's x. You need the mean, that's mu, and you need the standard deviation, that is sigma. And of course, we know the equation to calculate the z-score is x minus mu over sigma. Once you have the z-score, if you're looking for the probability less than that z-score, then you grab your table and you flip it to the correct side. Is it a negative z-score that you have, or is it a positive z-score that you have? But all these probabilities will tell you the probability less than that z-score. So of course there you got to be careful. What is the question asking? Because perhaps it's asking the probability over that z-score, in which case you have to take a complement. Maybe you have a problem where it's asking the probability between two z-scores. Then you'd find the probability less than the bigger one and subtract the probability less than the smaller one, right? Okay, so with that recap, let's take a look at number 7. The San Diego Police Department reports that the average time to respond to a 911 emergency call is 11.3 minutes. These times are normally distributed with a standard deviation of 4.4 minutes. Okay, so we got our information there. They tell us the average, 11.3 minutes. They tell us the standard deviation, 4.4 minutes. Let's keep reading. If 200 calls are randomly selected, how many will have a response time of less than 8 minutes? Okay, so that very last number is the data value less than 8. So 8 is our x, and we're going to find a probability less than. There is one extra element to this problem. It's the fact that in the end, they're actually not asking for a probability as the final answer. They're saying if 200 calls are randomly selected, how many of those will have a response time less than 8. So here's kind of our game plan. So we're going to find the z-score that fits the information they gave us. In this case, we're then going to look at the probability less than that z-score. And then finally, we're going to think, hey, how do we take into consideration that they're considering 200 calls, and how many of those 200? So what's that all about? Okay, well, we'll get to that at the end. Let's begin by finding our z-score. And so, okay, we can just plug all those numbers in, and I'll just show you what I got here. So we know x equals 8, mu equals 11.3, sigma equals 4.4. We'll put those into our formula. 8 minus 11.3 divided by 4.4, and make sure you round to 2 decimal places. I forget if this needed rounding or not, but I imagine it did. 2 decimal places is what you want, because that is the accuracy of our z-table, how we look up these probabilities. Okay, so we found z equals negative 0.75. So we found the z-score. Let's move to the probability less than. And you can see I already have the answer there. That's okay, we'll walk through it. So we're looking for the probability that z is less than the negative 0.75. So we're going to go to the negative side of our z-table and look up negative 0.75. I see negative 0.7 there. So 0, 1, 2, 3, 4, and 5. 0.2266. All right, and so there's where we get the 0.2266. And now here at this point, we have the probability that the response time to a 911 emergency call will be less than 8 minutes. We got the probability. But that's not what they asked. They said if 200 calls are randomly selected, how many of these 200 calls would have that response time less than 8 minutes? So what do? Well, we think, well, we know the probability of it happening, and if there's 200 calls, then it's just one more step, one more small step. We can take our probability, multiply it by the number of calls, and that is how many we would expect to have a response time less than 8 minutes, because that is our answer there of 45.32. That is 22.66% of 200. So we find that by multiplying 200 by our probability. Now, it makes sense in this case to round it to the nearest whole, since we're talking about emergency calls. Either way, I would accept this on a test, or I would accept 45 calls on a test. So there you go. Okay, let's move to number 8. Number 8 is interesting. So number 8, they are going to give us, they're going to switch things up. So they're going to give us different information, and we have to solve for a different part back in our formula here, our Z formula. Let's read it. The miles per gallon of gasoline, which we often refer to as MPG, for a new model car is normally distributed with a standard deviation of 4.5 mpg. Okay, let's read that one more time. The miles per gallon for a new model car is normally distributed, okay, with a standard deviation of 4.5. So they'll tell you the miles per gallon, say, on the sticker on the new car. This car gets 35 miles per gallon. But it doesn't always get exactly 35 miles per gallon, right? That's they find that from analyzing a lot of data and probably taking an average. So really, in some circumstances, cars get different miles per gallon. City highway we know about, but going uphill, downhill, even the driver, how fast they're accelerating. Okay, but so they know the standard deviation is 4.5 miles per gallon. Also, only 12.1% of these new cars get less than 20 miles per gallon. 12.1% of the new cars get less than 20 miles per gallon in their testing. So what is the mean miles per gallon of one of these new cars? Okay, and we can see they're asking for the mean, which we know is mu. So if they're asking for the mean, it must be that we can figure out, or they told us the other 3 parts of this equation. So we're going to fill in the x, the sigma, and the z, and then we will solve that for mu. Okay, let's see how this plays out. A couple of these, they just tell us. So they tell us the standard deviation. Okay, there's kind of my note saying the same thing. So we're going to use our formula, and we're asking, what is the mu? What's the mean? So they tell us sigma, right? So that's nice. The standard deviation is 4.5. They also tell us x, which is not the easiest to identify, but they do tell us x. And as you're looking at those, the x is the 20 miles per gallon. X is 20. Why that? That's like the data value. Right? So some percentage of these get less than 20 miles per gallon. And even the less than tips us off that that's the X value, because we're always looking at being less than the data value, or maybe more than the data value, or between 2 data values. So the fact that they say less than 20 miles per gallon makes it very clear that our data value X is the 20. Now, in order to find the mean, we need one more piece, right? We need the z-score. They don't tell us the z-score explicitly. We're going to have to do some work to find it. But they do give us one piece of information which will be enough to get there. It's the 12.1%. the fact that only 12.1% of these cars get less than 20 miles per gallon. How's that going to work? Okay, so we don't know the z-score at this time. We're going to find it. How are we going to find it? Find the z-score for the probability that z is less than z equals, and there's the 12.1%. This is like a percentile question at this point. They're giving us the percentage. They're saying it's a less than. So we can use our table to work backwards to find the z-score that would give you 12.1%. Okay, so we're going to grab our z-table and we're going to use it backwards. So we're going to look in the middle of the table to find 0.121, and then we're going to like triangulate the z-score that would have given you that. So first question, after you grab your table of z-scores, should you look at the negative z-scores or should you look at the positive z-scores? And well, 12.1%, that is less than 50. So look at the negative z-scores because it'll be on the left side, the lower 50% of the data. You would have figured that out pretty soon anyway, but it saves you a little time that way. Okay, so we're looking in the middle of the table for 0.1210, 12.1%. Let's see if we can find it. Let's see, so this is 0.0, we need 0.1, 0.12, 0.12, 0.1210, there it is. There's 12.1%. Okay. Where did that come from? They came from negative 1.17. Negative 1.17 if we work backwards. So we just figured out the z-score. That fits the rest of our data. Okay, so once we have the sigma, the x, the z, we can put those into our formula here. Negative 1 point, and I'm showing you the answer, but okay, negative 1.17 equals 20 minus mu over 4.5. And we're going to solve this for mu. How do we solve this for mu? We can multiply the 4.5 over to the left side. Multiply that over and you'll get negative 5.265 equals 20 minus mu. And then how do we get our answer here? Well, you could probably argue there's some more steps in between. But what you could do is add mu to this side. And then at the same time add 5.265 back over to this side. What did I do right there? 5.265. So those cancel out and you'll get mu over here by itself, and 20.5, 20 plus 5.265 gives you mu equals 25.265 mpg. So in a kind of a clever way of going about it, we can work backwards. And probably the most clever piece of this was using that percentage to work backwards to find the z-score. So recognizing that and then knowing how to do it as well, and then seeing, okay, now we can put the z, the x, and the sigma into the formula, and we can solve that equation for mu, multiplying that over and then adding, things to both sides that way. Not a simple problem. It may seem simple. There's not a lot of work necessarily, but knowing what to do and how to approach something like practice number 8, it takes some skill. It takes some practice with those to recognize, oh, they're looking for the mean, so it must be, I'll still use this formula, but I'll fill in the other 3 pieces. There may be questions in the homework where they're asking for sigma. And so if they're asking for sigma, then you will be able to fill in the z, the x, and the mu, right? Perhaps they're even asking for x, and you have to find z, mu, and sigma, and then you solve that for x, right? That could happen. And of course, the trickiest one, and the one that probably takes the most work, is identifying that z, because they're never going to tell you the z-score, or usually they don't anyway. They'll tell you a percentage, and then you have to use your table backwards to get the z-score they're looking for. Okay, let's stop this video right here. We'll do practice number 9 next.